this example, before I actually found the values of x, in other words, I used the completing the square to solve for x. In this case, I want to put this in completed square form. So it's slightly different. Let's have a look. So I'm going to say, well, we've got 2x squared plus 4x minus 3. I'm going to make it equal to 0, and I'm going to add 3 to both sides. So I'm not solving for x this time, yeah? So I've got 2x, and what I'm going to do is I'm going to divide everything by 2. Divide this by 2, divide this by 2, and divide this by 2. So, of course, that leaves me with an x squared. 4 divided by 2 is 2, so it's plus 2x equals 3, and I've got a 3 on 2. Now, I'm going to take the b bit and divide it by 2 and square it. Do the same thing to both sides. So I've now got an x squared. Notice it's all the same so far. Oh, in fact, I can now make this straight into the perfect square. What am I doing? I can say x in brackets, here it is, square it. This is a 1 in there, so I'll put plus 1 is equal to, well, 3 on 2 is 1.5 and 1. And 1 plus 3 on 2 is going to be 5 on 2. Now, what I want to do now, though, is not make it equal to 0. I just want to keep it as a square. So I'm going to take the 5 on 2 back onto the other side. So it's going to be, the answer is going to be x plus 1 all squared minus 5 on 2. Now, you'll recall I divided everything by 2. I've now got to undo that process by multiplying everything by 2. So I'm going to say, I'm going to multiply that by 2, and I'm going to multiply this by 2. So the answer, the final answer, is going to be 2x plus 1 all squared. 2 divided by 2 leaves me with minus 5. And there is the completed squared form of the original equation, which is this one here. So here is the answer.